I think they just give you the lowest age, like lowest life expectancy with like, you know, like she said, with smoking and drinking and stuff.
You don't want to know that. I don't want to know I'm supposed to die.
I mean, you do. There's a life
Yeah,
expectancy
you
for
do
just
know.
healthy people. Yeah.
It's like 70 years old for the average person.
But you can die only. I still got about 52 years.
Hey,
All right.
Hey, we ain't do Tom.
Tom, okay.
Oh, I'd say probably like I think I have like just the most random interests. Like maybe I don't think it's really unique, just like historical stuff. Like I'll just like research like the most random thing like extensively and like travel around the different historic sites. Like I used to explore like abandoned mines and stuff in Wyoming. Like,
That's unique, because I could care less about anything historical, personally. But I love that question. That was a great question. And like I said, I mean, we could just talk all day about it. But we have to move on. So now we're going to practice what we just learned. These start out, well, the first one's super easy. So I want to go over how you answer this. So the first question they ask is, what is the parent graph? What they're meaning here is, what is the naked graph? What is the basic shape? So g of x, the function, is x squared minus 1. If you take off the minus 1, that is the parent graph. Now, this is going to come up again on another assignment, so I want you to know how to answer the question. So it says, what's the parent graph? Well, the parent graph is just an x squared. Now, right here, I want you to kind of give yourself a visual of what the parent graph, before we make any shifts, this would have just been an up U quadratic. I'm just going to draw a little tiny picture right there, just to get in my mind, what does the parent graph look like before I make the transformation? All right, then we look at our transformation. This is a -1, and it is detached from x. It is not attached to the x. It's hanging out in the back. And you probably don't have them memorized yet, but if it is detached, it is going to move as expected vertically. So it's going to do what you think it would do in the vertical direction. So what would you think a -1 would do? Down 1. So the transformation is that it's been shifted down 1. Now, it's hard to see, but this actually has graph paper. It just didn't photocopy very well. So go down 1. Let's just say this is -1, and then drop your quadratic. So you take the parent function. You don't graph the parent function. You just kind of put it right here just to get your mind straight. And then you make your shifts.
You are recording,
I
right?
think so. I double checked it. I just hope the volume's on and all that good stuff. All right, number 2. They ask you for the parent graph. In other words, before any shifts or any rotations or any vertical or horizontal changes, what was the naked graph of number 2? Absolute value of x. That is correct, which, like Robert said, is a V. Just draw yourself a little tiny shape over there, just so you know what you're supposed to be looking for here. This is not a vertical snake. It's not a horizontal snake. It's not a shooting star. It's not a volcano. It's going to be a V. Then we have to look at our transformations. Now, this problem has 2 transformations. 2. Let's look at the -1 first. Is -1 attached or detached? It's attached. So, again, you probably don't have it memorized, but it's going to move it in the opposite direction horizontally. So, what's the opposite of -1? Right 1. That is correct, Caleb. It's going to move to the right 1, and we got to look at this other number. All right, we see that there's a number in front of x. It's 2 over 1, and that number is greater than 1. Now, again, this is not slope. It is not slope. Do not tell anybody that Miss Smith said this was slope, because that is not true. But it does kind of give you a guide for what's going on. So if we go up to, we're going to stretch it. I'm going to go ahead and write that word, and then we'll actually plot it. All right, so we know we've got a V, and we know we need to move right 1. So go right 1. Like I said, this actually is graph paper, but the graphs just didn't show up very well. And then this 2/1, I cannot stress to you enough, this is absolutely 100% not the slope. We are not plotting points here, but it is a guide to let you know if the thing is stretching or compressing. So if you were to go up 2/1, up 2/1, up 2/1, up to left 1, up to left 1, you can kind of see that this is stretching and getting more narrow. And that is true because it's greater than 1. And if you have a number in front of x that's greater than 1, it's going to stretch your graph. All right, number 3. First thing you want to figure out for yourself is what is the basic graph, just to make sure you've got your shape correct. So the parent graph would just be an x cubed, and we know that an x cubed is a vertical snake. So we're going to be something like this. An x cubed has to go through quadrants 1 and 3, and it's okay for it to equal 0, so it would go through the origin. All right, then I start looking at these shifts, and there's 2 of them. This is a -2, and it is detached from x. It is hanging out at the back. It is not grouped in parentheses or absolute value bars or a radical. So it is going to move as expected vertically. So what would you expect a -2 to do?
Go down.
It's going to go down 2. So it's going to go down 2, and we got to look at this negative in front of the x cubed. All right, so now we're looking at this negative, and this negative is also detached. Now, again, I'm not flipping back through my papers. You would go back here and say, all right, if it's deep, here's my paper. Sorry, let me slide it down. If it's detached from x, it's going to do my little handstand move. It's going to flip over the x-axis horizontally. So I'm going to say down 2 and flipped. You can say rotated along the x-axis if you want to, but I'm just going to say flipped. So first, let's move down 2. So 1, 2. And then when I flip it, it's going to go from 1 and 3 to 2 and 4. So it's going to be a vertical snake, but it's going to go this direction. All right, it's been a while since we've done one like number 4, so let's look at the parent graph. All right, this one, the parent graph has an x cubed in the denominator. So the parent graph would be 1 over x cubed in the denominator. And we know that those cannot equal 0 because you can't have 0 in the denominator, so it can't cross this line right here. And since that's odd, it has to go through quadrants 1 and 3. This is why you have to know your naked graphs. So the parent graph would be a slide in quadrant 1 and a slide in quadrant 3. That's the parent graph. I have got to know my basic functions or my parent graphs before I can do my transformations. All right, this one has 2 transformations. Would y'all say that this one is attached or detached? Attached. If it is attached, it moves in the opposite direction horizontally. So what's the opposite of +1? Yes, it's going to move to the left 1. And this number is detached. Now notice, I want to tell you, we have not done any adding, subtracting, multiplying, dividing, factoring, foiling, radicals. We haven't done any type of calculation today. Okay? So if you know, algebra is not your jam, maybe this is going to be easy for you because it's totally different. All right, if it's detached, look, flip through your notes. This was the second transformation. It's going to move it as expected. So this one's going to go down 2. So let's get our point in the right spot. We need to go left 1, down 2. So left 1, down 2. I know this is hard to see, but technically it is graph paper. Now, this is something we'll get into greater detail later, but this is a point where your graph is reflexive around, and it cannot cross these red lines. So it's not your point of origin, but it's the origin has been, you know, the origin is 0, 0. So this point has been shifted left 1 and down 2. But it still has to have the basic shape of our parent graph. So it's going to get close and swoosh to the red here. And it's going to get close and swoosh to the red there. No, this one actually, okay, good question. He said, will it never be 0? This one actually can't cross at -1 because what's -1 plus 1? 0. So that's why we have an asymptote. This time our asymptote is at -1, not at 0. Because if you solve this, x plus 1 cannot equal 0, therefore x cannot equal -1. That's why our little asymptote shifted over. So this time it can equal 0. Because if you plug in a 0, 0 plus 1 is 1, 1 divided by 1 is 1, so you're good to go. All right, number 5 is an interesting little guy here. What is, we just had a packet on this, -3x minus 2. What kind of equation is that? It's a line. What form is this? We just had a pink packet on it. A linear equation in what form? Y equals mx plus b. This is slope. Your slope is -3 here. This is your slope. And this is your y-intercept. Because this is a linear equation. Now, it's the only one I think we'll ever have on this particular packet that is linear. But this one's just a line. So the parent function is y equals x, which is a vertical line. Just looks like that. All right, it's going to be moved down 2, so drop it down 2, and your slope is -3 over 1. In other words, you're going to go down 3 and then right 1. So first thing you do is drop it down 2 and put a dot, 1, 2. I apologize that you can't really see the graphs on this. We had some people that missed this. They didn't know what to do with the negative slope. This is a -3, but a +1. So it's going to go down 3 and then to the right 1. Even if you can't see it, there's a +1. So go down 3, 1, 2, 3, right 1. 1, 2, 3, right 1. Now this truly, I missed it. This truly is, of all the ones we've ever done, this truly is the slope. It really is the slope because it really is slope-intercept form. That's why I told you earlier on all those other ones that we looked at stretched and compressed, and I said this is not the slope. It's not the slope because none of those were in slope-intercept form. This is the only one we've done that was in slope-intercept form. All right, the last one, number 6, and then I want to change gears maybe a few minutes. We know the parent graph is just absolute value of x, so just put that here. And we know the parent graph of that is a perfect V. We see that the +5 is attached to the x by these vertical bars. And then this is detached. So we got a number that's attached. We got a number that's detached. The attached number is going to move it in the opposite direction horizontally. So plus 5 is actually going to go left 5 and as expected on the -2. So down 2. So go left 5, down 2. And then it's going to be a V. All right. I'm going to let y'all work on this page with your neighbor. If you don't have a neighbor, like Dante can either join Kayla and them or the guys behind you or Matthew or Tyler or whatever. Let's work on page Z for a few minutes with our neighbor. Page Z. Let's work on that.